Welcome to the Section 10 Marathon. 3 problems chain the radical technique simplification with variables, rationalization, and solving a radical equation. Each one exercises a different muscle, and finishing all 3 confirms the toolkit is ready. Problem 1 simplifies a radical containing both a numerical coefficient and variables. The numerical part needs a perfect square factor extraction. The variable parts need pairing for square root and absolute value where the index is even. Problem 2 rationalizes a fraction with a binomial denominator that includes a radical. The conjugate trick converts the binomial denominator into a difference of squares, which simplifies cleanly. Problem 3 solves a radical equation. Isolate the radical, square both sides, solve the resulting quadratic, then check candidates in the original. Squaring can produce extraneous solutions. Problem 1. Simplify the square root of 40, 5x squared y cubed. Find perfect square factors in each part of the radicand. 40, 5 equals 9 times 5, y cubed equals y squared times y. The factorizations expose what stays inside and what comes out. Split the radical square root of 9 times x squared times y squared multiplied by square root of 5y. The first factor is a perfect square. The simplified form is 3 times absolute value of x times y times the square root of 5y absolute value on x. Because the index is even and x could be negative, y stays plain because the original radicand y cubed forces y to be non-negative. Problem 2. Rationalize 6 over the square root of 5 minus 1. The denominator is a binomial with a radical, so use the conjugate. The conjugate of square root of 5 minus 1 is square root of 5 plus 1. Multiply numerator and denominator by the conjugate. The denominator becomes square root of 5 squared minus 1 squared, which equals 5 minus 1 equals 4. The numerator becomes 6 times the quantity square root of 5 plus 1. Simplify by dividing 6 and 4 by their common factor of 2. The final form is 3 times the quantity square root of 5 plus 1 divided by 2. The radical is gone from the denominator and the answer is in standard form. Problem 3. Solve the square root of 2x plus 3 equals x minus 3. The radical is already isolated. Square both sides. 2x plus 3 equals x minus 3 squared, which expands to x squared minus 6x plus 9. Move everything to one side. X squared minus 8x plus 6 equals 0. Use the quadratic formula or numerical solving to find candidates. Check both candidates in the original equation. Carefully test each x value to confirm the left and right sides match. Reject any that produces a radical of a non-perfect square that does not equal the right side, or a radical of a positive that equals a negative right side. The valid solution is the one that satisfies the original equation. 3 takeaways from Section 10. They cover the 3 branches of radical algebra you will use repeatedly. Simplifying. Factor the radicand, pull out perfect powers matching the index, and use absolute value when the index is even. Variables follow the same rule as numbers. Every pair under a square root, every triple under a cube root comes out as one factor. Rationalizing. Single radical denominator, multiply numerator and denominator by that radical. Binomial denominator with a radical, multiply by the conjugate. Both moves rely on the difference of squares identity from Section 8. Solving radical equations. Isolate the radical, raise both sides to the index, solve the resulting polynomial equation, and always check each candidate in the original. Squaring and other even power operations can introduce extraneous solutions that look right algebraically but fail the original equation.